Alright, so in this problem, I have 5 to the power of x plus 1 minus 5 to the power of x is equal to 100. So obviously I want to find the value of x here. So for my solution, I'm going to start off by using the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So 5 to the power of x plus 1, that's going to equal 5 to the power of x times 5 to the power of 1. And now I have this minus 5 to the power of x is equal to 100. Now from here, I'm going to factor out 5 to the power of x. So I get 5 to the power of x times 5 to the power of 1 minus 1 is equal to 100. And now 5 to the power of 1 is the same thing as 5, so I have 5 to the power of x times 5 minus 1 is equal to 100. And 5 minus 1 is 4, so I have 5 to the power of x times 4 is equal to 100. Now we want to isolate 5 to the power of x, so I'm going to divide both sides by 4. So I can have 5 to the power of x is equal to 25. And 25, this is the same thing as 5 squared. So I have 5 to the power of x is equal to 5 squared, meaning x is equal to 2. So now to check, my original equation was 5 to the power of x plus 1 minus 5 to the power of x equals 100. And x equals 2. So I have 5 to the power of 2 plus 1 minus 5 to the power of 2 is equal to 100. 5 to the power of 2 plus 1, that's 5 to the power of 3 minus 5 squared is equal to 100. 5 to the power of 3 is 125 minus 25 is equal to 100. And this is 100 is equal to 100. Alright, so in this problem, I have 32 to the power of x plus 5 is equal to 5. So to solve this, I obviously want to find the value of x. So for my solution, I'm going to start by rewriting my equation. So I have 32 to the power of x plus 5 is equal to 5. Now 32, I'm going to rewrite as 2 to the power of 5. So now I have 2 to the power of 5 to the power of x plus 5 is equal to 5. And if I have something in the form a to the power of m to the power of n, this is going to equal a to the power of m times n. So 2 to the power of 5 to the power of x plus 5, that's going to equal 2 to the power of 5 times x plus 5. And this is equal to 5. Now, I'm going to go ahead and take the log on both sides. So I have log 2 to the power of 5 times x plus 5 is equal to log of 5. And if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So log of 2 to the power of 5 times x plus 5, I can move 5 times x plus 5 to the front. So this is going to equal 5 times x plus 5 times log 2 is equal to log 5. Now I'm going to divide both sides by 5 times log 2. So then these two cancel out, and I'm left with x plus 5 is equal to log 5 over 5 times log 2. And now if I subtract 5 on both sides, I get x is equal to log 5 over 5 log 2 minus 5. Alright, so in this problem, I have x to the power of x plus 1 is equal to x. So to solve this, I'm going to start by subtracting x on both sides. So then these two cancel out, and I'm left with x to the power of x plus 1 minus x is equal to 0. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So x to the power of x plus 1, this is going to be equal to x to the power of x times x to the power of 1. Now I have this minus x is equal to 0. Now if I factor out x, I get x times x to the power of x minus 1 is equal to 0. So now this gives me two equations. I have x is equal to 0, and I have x to the power of x minus 1 is equal to 0. So x equals 0. This is already a solution. Now for x to the power of x minus 1 equals 0, I'm going to add 1 on both sides. So then these two cancel out, and I get x to the power of x is equal to 1. Now, because x has to be the same number, we obviously know that, well, what number to the power of itself is equal to 1? That's going to be 1, right? Because 1 to the power of 1 is equal to itself. So x is equal to 1. And there's no other number that when you take the power of itself is going to equal 1. Meaning x equals 1 is the only solution to this equation. So now to check, the original equation was x to the power of x plus 1 is equal to x. So x to the power of x plus 1 is equal to x. And our first solution is 0. So if I plug in 0, I get 0 to the power of 0 plus 1 is equal to 0. Now 0 plus 1 is 1, so I have 0 to the power of 1 equals 0, and 0 to the power of any number is itself, so I get 0 equals 0. Now to check for 1, I get 1 to the power of 1 plus 1 is equal to 1. 1 plus 1 is 2, so I get 1 to the power of 2 is equal to 1, and 1 to the power of any number itself, so 1 equals 1.